Hello, this is the third video of the Hyperbolic Functions 1 series for OCR Pure Core Further Mathematics, and we will be looking at hyperbolic function identities. We have already met for one identity, tanh x equals to sin x divided by cos x. This is true for all values of x. You will note that it is very similar to the circular trigonometric functions identity where tan x is equivalent to sin x over cos x. In general, hyperbolic functions do have similar identities to the circular trig functions, but you need to be careful of the signs. Simplifying the following expression, substituting the exponential forms given for cos x and sin x would give us a half e to the x plus e to the minus x all squared minus a half e to the x minus e to the minus x all squared. We take out that quarter and expand. That would give us e to the 2x plus 2 plus e to the minus 2x minus e to the 2x minus 2 plus e to the minus 2x. You can see that the e to the 2x and the e to the minus 2x terms will cancel out, thus leaving us with a quarter of 2 plus 2, or 1. This gives us the identity that cos squared x minus sin squared x is always 1, and it can be used in a similar way to the circular trig identity, where we have that cos squared x plus sin squared x is equivalent to 1. But do please notice the negative sign. So these are the two hyperbolic function identities that you really need to know. Others may be derived, such as the equivalent to double angle formula. If we start here on the right hand side, we would see that cos squared x plus sin squared x would equal a quarter, and this is using the same work as we did when expanding these on the previous slide. So that's the definition expanded. And we can see here that in this case it is the 2's that get cancelled out, leaving us with a quarter of 2e to the 2x plus 2e to the minus 2x, resulting in the half e to the 2x plus e to the minus 2x, which is therefore cos of 2x. Here we have an example of solving equations using some identities. This often uses the same strategies as when we are using circular trig identities. So for example here, we would rewrite the equation we're given as being 1 plus sin squared x using this identity here minus 5 sin x equal to 1. If we arrange this, we get 3 sin squared x minus 5 sin x plus 2 equal to 0. At this point, if we wished, we could replace the sin x with u. Some people prefer this when they are solving quadratics. We can then see that this would factorise to give us a solution that u equals 2/3 or 1. Substituting back in, that would give us that sin x equaled 2/3 or 1. We could solve this, as we did in previous videos, by forming a quadratic in e to the x, using the definition here. For the moment, just accept that the values of x relating to those sin x values are 0.625 and 0.881. You can verify these by putting them back into the equation if you wish. Other solution methods, such as using the inverse sin function, will be considered in later videos. In the next video, we will differentiate and integrate hyperbolic functions.